This conference will now be recorded.
Hello friends, I hope all of you are doing well. So in this add-on course, what have we done till now? Let's see. So we have done around 5 sessions on core Java. There is a lot to come yet, mostly on important topics like uh, collections framework, multi-threading, OOPS concepts, exception handling. So there are many videos which are yet to come in core Java. In Linux fundamentals, we have talked about the basics of Linux commands and all, and we have covered 2 sessions. Big data on cloud, we have covered 4 sessions, mainly on Spark with AWS Flow, right? And in Scala, functional based programming, we have covered 4 sessions, and data structures, we have covered 5 sessions till now. Now, I was talking to few students and I got to know the most important area where they face a lot of issues is when in an interview some coding questions are asked. So what I thought of, okay, let me try to create 2 series of videos. One is specially for interview questions which are coding type. That means like practical questions, right? So this will be one series which I am starting from today. Also, the other series will be interview logical questions where they ask you a question and they expect the answer, right? So interview logical questions on big data, right? So there are 2 series which I will start. One is the coding based and other one is normal question answer session. So today I am going to start this one, coding practical. And what I am trying to start with is some of the questions which are recently asked in interviews. So we will start with that, right? So here I have the first question for you, right? So as the name suggests, interview questions, practical series coding, which are recently asked in interviews. And this question, whatever I am planning to cover today, is the one that is asked in HCL very recently to one of my student. This question was asked. Now the question says that given an input data set with name, age, and city, right? So input is name, age, city in a particular data set. Now what you need to do is you need to see if age is greater than 18, then you need to add a new column that's populated with Y. Otherwise populate that new column with N. That means if age is greater than 18, the fourth column will have Y. If age is less than or equal to 18, it will have N. So I hope the problem statement should be quite simple to understand. Now again, there are 2 problems here. One is that you need to solve this problem using the RDD approach, the raw RDDs approach. And the second problem statement that you need to solve is you need to do it using data frames or Spark SQL, whatever you want, right? So these are the 2 problem statements we have now. So for our explanation purpose, I have created this database with these 3 columns. Let me show you that database, a small database. I have created it on desktop and let me say cat. Uh, the name of dataset is dataset1, right? So you can see I have created this dataset where first column is name, age, and city, right? So we have around 1, 2, 3, 4, 5, 6. So basically we have 6 rows in this data set. I mean, even if there are 6 lakh rows, that does not matter if we build the correct logic. However, each row has 3 columns, name, age, and city, right? Let me just expand it a bit. So I hope you can understand this data set. Now the problem statement says that if age is greater than 18, in the fourth column, you should have Y. And if age less than 18 or age equal to 18, then the fourth column should have N. That means given this first line as input, the fourth column should have y. Second row should also have y. The third row should also have n. The fourth row should have y. Fifth row should have n, right? Likewise, correct? So you can see the problem statement seems to be quite simple, but it becomes really difficult if you are not hands-on with coding and you are trying to approach this. So let us try to solve this problem using the RDD approach. So let's solve the problem 1. So you can see this, I am in my Eclipse IDE. Throughout our course, we have worked on this bunch of imports, object name, right? And then a main method. And logging level, I'm setting it to error so that I do not see any irrelevant info messages. And I am creating the Spark session because in Spark 2, we create the Spark session, right? So I have basically created the skeleton of the program so that I do not have to work on these aspects because I want to write my logic only. And if you were to write this code in Spark shell, none of these things were required. You could have directly started from your logic itself. But just since we are trying to do in our IDE, all this boilerplate code or the code which does not really make sense is required just to make our program work. However, this does not have any logical part as such, right? Bunch of imports, then object name, right? Object, you can think it is like a singleton class that has already one object created. Then we have the main method because every program should have a main method. Otherwise, when you say right click run as, you won't see Scala application. You won't see an option to run the program if you do not have a main method. We are turning off the logging level to error so that we do not see any information messages, because if we do not put this, there will be so many information messages that our output will be kind of lost. And then we are creating the Spark session, right? Now after this becomes comes the logical part. So let us try to understand what we have. So first of all, you can see this spark.spark_context.text file. I want to read the data as an RDD, raw RDD. So I have to use the Spark context. And as I said, Spark is like a umbrella under which many contexts are embedded. Spark context is also included inside Spark session. So that's why we say spark.spark_context, right? If we are writing this program in our, let's say, Spark 1.6, we could have just said sc.text file. So spark.spark_context is similar to sc, right? And we want to read a text file, correct? So the location of my text file is /users/trendytech/desktop dataset. This is the path where my dataset resides. How do I know? I can just say pwd here. You can see users trendytech desktop, and then the name of my file is dataset1. So I have given the complete path of the file, right? And then I want to store the results in RDD1. RDD stands for resilient distributed dataset. You already know about it, right? Just have a look. Now I want to just see whether my RDD is holding the data or not. So what I'm saying, RDD1.collect.forEach_println. That means I should be able to see the results. Let me see that. Run as Scala application. Right? So you can see we are able to print the results, and it's a RDD which is created now. Okay, that's fine. Now what to do next? Right? So for each input row, we want one output row, right? Now basically we have to apply some transformations, right, in order to get our output. So for each input row, we want one output row. So which transformation should we use? You remember, one-to-one mapping means a map transformation, right? So what we can do is we can say rdd1 dot map. Now I could have just brought in the code and showed you, but I thought of, okay, if I start typing, you might get a better feel of it, right? And then here I need to, let's say, write some method name. Let's say mapper. Mapper will be one function which I will create, right? So let me write the mapper method here somewhere. Def mapper input, or let's say line string type equal to, right? So what does this say? Mapper is a function, right, which takes, some one line as input, and then finally it is the body, right? Now this line, whatever we get as input to this mapper method, we want to split it based on comma, because in our data set, if you see, the data is comma separated. That means line might be something like this. Sumit 30 Bangalore, right? So what you want to do is you want to say line dot split based on what, comma, and this will basically give you an array. So you can just say where or well, let's say fields, any name you can give, does not matter, equal to this, and fields will be an array. If you hover on it, it will say it's an array of strings, right? Now you will put your logic saying if fields, now remember, fields of 0 will be Sumit, fields of 1 will be 30. So we are interested in fields of 1, that is the age, right? So if fields of 1 is greater than 18, then we want to return something. What we want to return? A tuple. And in tuple, what we want to return? Fields of 0, comma, fields of 1, comma, fields of 2, comma, and then we want to have y here because age is greater than 18. But now when I say fields of 1, it will be basically of string type, because you see inside this array everything was a string. But when you want to compare it with the number, then you need to convert it to integer, right? So to int, right? If else what we want to return? We want to, I will just copy paste things from here, n, right? So you can see this, if the age is greater than 18, we want to have this, return this, otherwise return this, correct? This is the definition of my mapper method. I have called this from here, right? Now let me try to capture it in some other RDD. Well, RDD2 equal to this, and I will now try to print this rdd2 dot collect dot for each print ln, right? So let me try to run as Scala application. So you can see very well that okay, whatever we wanted, we have done it properly. That means the fourth column is populated for every row, and wherever age is greater than 18, it is Y, otherwise it is N. Now additionally, if you want to, let's say, store it somewhere, that means you do not want to collect it, rather you want to store it to a file. What you can do is rdd2.save as text file, right? And here you can give the path. For example, users trendy tech desktop / my output directory. Let's say I'm giving some random name. Okay, I have done this. I will copy this also because I have to check the results here. Now let me try to run it. That means in this case it won't show me this results, final results, rather it will save it to the text file, right? So let me go. So these results are the previous, whichever we have printed. You see this, right? Normal RDD, the base RDD we have printed. This is this result, but the output we are not showcasing. How to check? We need to check at this location. Let me go back. So let me say cat this / start. So you can see our results. So what we have done is we can just again I will just show you. We created a Spark session and then we loaded the base RDD. After that, what we did is we applied a map transformation on each element. On each row, we applied a map transformation where we have this logic that if age is greater than 18, we need to return this tuple of 4, otherwise return this tuple of 4, right? And we are capturing it as part of RDD2, and then we are either showcasing it on the screen directly or saving it as text file, right? So I will just put this code here for your reference. Solution 1. That means the RDD approach, right? Now, in this case, whatever function we have defined, we are calling that. Can we convert this to an anonymous function? Yes, why not? We can. So first of all, let me not save it to a file now because we have already seen it. It will work. We will display it on the screen only, right? But now what I want to do is I want to convert this function into an anonymous function. That means let me take portions of it, whatever I want. So I should say X implies, right here I need to write the body of it, and I will copy things from here. I will say line because I have given it line, right? And I will remove it. I will just structure it well so that you can understand it very well. So you can see this here. Since I want to write this function one time or I do not want to reuse it, that's why I can define it inside this also. right? And this is called as anonymous function because I mean you can just check that out. We are writing a function without a name. Does this function have a name? No, right? So what it says is map will take one line and on top of that it do a split based on comma. We get some whatever array and then we are checking if array of 1 greater than 18 or not. If it is, then return this, else return this. So instead of defining a separate function, we can write it inline also. And this is called as anonymous function. This will also work. Let me show you. Run as Scala application. So you can see this is your output. The same output, whatever we were getting previously. Just have a look. Right? I will also just take it and put it to the document. So I will just mention here solution 1. Anonymous function, right? And this one is without anonymous function. Just for the sake of understanding, I am writing this without anonymous function. Okay, so I hope you understood this well. And the whole purpose I mean wanted to write the code in front of you is that you will get a feel of it. Otherwise, if I just showcase you, might be you won't understand well. So I hope this looks to be pretty easy, correct? And if you really want to save it to a file, you can say rdd2.save as text file and give the path. Okay, fine. Now let's jump to the second problem. The second problem says that do it using data frames or Spark SQL. I mean data frames, Spark SQL, almost the same things. So we will try to do it using Spark SQL. The same thing, right? So again, I have the structure ready, the same structure, and we will take it forward from here. Same problem, we need to do it using the data frame or Spark SQL approach. We should not be using the raw RDD in this case, right? Now we have created the Spark session, fine. After that, what we are doing, we are loading the file as RDD because the data does not have any headers, right? Any structure, then of course we have to load it as RDD. There is no other choice, right? Let me show you. Our data looks like this. Does it have any headers and all? No. Then how can you directly create a data frame out of it? You cannot, because this is a raw data without any field names. So you cannot create a data frame directly out of it. It has to be a RDD initially. And that's what you created using this. And then you can just print it and see that is it displaying the RDD data or not. So you have to go step by step. So you loaded a RDD and you are trying to print it, it prints, right? It shows up. Now, what you need to do is, out of this RDD, you want to create a data frame. So remember, RDD is nothing but raw data. Data frame is nothing but structured data. That means on top of this RDD, you want to define a structure, right? How to define a structure? Using a case class, right? So let me define a case class. Case class, let's say person, right? And then the first column was name, let's say name of type string, comma, age. Second column was age of type int, and third column is what let me see, what was the city, right? City of string type, correct? Now we need to call up map method on top of this rdd1.map. So basically what we will do in this map is we want to send an unstructured line, right? Unstructured line without any schema, but the output should be a structured line with some schema. So it is a one-to-one transformation where we send one unstructured line and we get one structured line, right? So if there are 100 lines, 100 raw lines, finally the output will be 100 structured lines. So it will be a map transformation that we should be using. Now again, let's give any name, mapper, fine. You could have given any name here, by the way, right? Now we need to write the code for mapper method. Def mapper, right? Now let's say line of type string equal to this, correct? Now what we will do is line dot split based on comma, and then we can capture it inside fields. So val fields equal to this. It can be any name, remember, it can be any name. Now what we need to do is that on top of these fields we want to impose this structure. So what we need to return is fields. So what we need to do is person p equal to, and then inside this what we need to do, we need to say fields of 0, correct, comma, fields of 1, fields of 2, comma, fields of 2, right? Person p equal to, right, we need to impose this structure. So we need to say person, sorry, I'm trying to write a Java kind of code, p person, it should be like this, right? P of type person, person is the thing, right? Case class person, name, age, city, right? And this is of int type. So fields of 1 dot 2 int, right? Fields, fine. Just a second. Let's try to refer person to int, say well, okay. Sorry. So what we were missing is well, right? Simple mistake. Val p person equal to person, fields of 0, fields of 1.2 int, fields of 2, right? That means we are trying to impose the structure, person structure on top of this raw data. That means the input is a raw line. However, the output will be a structured line. And then finally, what we want to return? P. Right? We want to return P out of it. Correct? That means we are returning a structured line. And then what is the output of this one? Right? So input you can see is RDD1 raw data. The output of it is RDD with structure. Right? You can see. Don't you feel this P is of type person which is structured? You can see this one. The structure is this one. We gave in a raw line to this function mapper and the output is a structured line. So the output of this is actually a structured RDD, but still it is not a data frame or a data set. But it is a structured RDD which we can convert to a data set now. Right? So we need to use the import, whatever is required. Import, right? Spark dot implicits, right? This is the import we need to do in order to convert a RDD to a data set. Dot to df, right? So that means initially it was a raw RDD. After we applied a map transformation, we got a structured RDD and then we converted it to a data frame. So remember, if you really want to call 2df, you should import this thing. Import spark dot implicits dot underscore. Underscore is like star, right? Now where you will capture here is well data or df1 equal to this, for example. Now if you hover on it, it says it's a data frame, right? So basically now it has structured data. If you really want to see what are the results, you can say df1.show. It will give you first 20 rows. Run as Scala application. Sorry. Run as Scala application. So you can see that out of this raw data, earlier the data was this, but now we get a structured data, a data frame. Correct? You can check that out. But still we have not received the results whatever we want. I mean, we have done the groundwork for it, but we have not worked on the logic whatever we should be doing in order to get the fourth column. Now we will be trying for that. So from this data frame, let us create a table because it's easy to work on a table and use Spark SQL than a data frame. So it's little bit hard to work on a data frame directly. So I personally prefer to create it into a table and then use Spark SQL. So let's try to do that. So we will say df1 dot create or replace temp view, and then we will give some name of the table. We'll say people table, for example. Any name you can give. Now we can query this table as if it is a SQL table, MySQL table or something like that. So we can say spark.sql select star from people table limit 5 or whatever, entire thing we can show. Dot show. Right? Run as skill application. So this will ease out things now that we have created a in-memory table where you can do SQL like operations directly. So you can see this is given by the table, right? So you can see things are becoming easy now. Now on top of it, what you can do is you can say, so you basically need to write your own user defined function, right? You need to write your own user defined function. You will understand. I mean, it's quite intuitive. Let me try writing that. Spark dot spark.udf spark.udf dot register, right? And here what I need to give is the name of the UDF. Let's say my function. I have given it the name my function. And now here I need to write the definition of this function. You will understand it gradually. So as of now, remember, this is the name my function, and then you need to write the definition of it. The definition of this is the input will be what? X of type string, correct? X of type int, because we want to give age as the input, right? So let's say we give 23. What is that? Integer type, right? Right, correct. And then the output will be if x greater than 18, if x greater than 18, right? So I will try to define it inside this braces. If x greater than 18, let me try to keep it in a better way. If x greater than 18, then what we want to give? We want to return y. Let me give it in one line only. Let me look clear. Just a second. If x greater than 18, return y, else return n. Correct? And then you just close this and then turn off this. I will remove it from here. In a single line, we have written this. That means you have written your own user defined function in Spark and you have registered this. The name of this user defined function is my function, and this is the functionality. The functionality is it takes an integer. If integer is greater than 18, it gives you y, else it will give you n. Simple thing. Fine. Now let's try to use this user defined function in our code. So I will copy paste this Spark SQL line because I have written it already. So what I want to say is select name, comma, age, comma, city, comma, city, comma. Now the fourth column. Now fourth column depends on age. And what we need to call is this function. My function of age, right? Now let's say if age here is 23, my function of 23. If 23 is passed here, what it will return by, right? So this will be 5, correct? So I hope you understood that for each row, let's say if 17 is given, right? So my function of 17, if 17 is passed here, 17 greater than 18 false, so it will give you n, right? So fourth column will be based on this, and we will give it some alias name to this column, right? This column should be given some name, let's say new column, right? So select name, age, city, comma, my function age. So if age greater than 18, it will give y, otherwise it will give n, and a new column will be created with the name new column from people table.show. Let me try running it now. So you can see we have created a new column and the values are populated based on our logic. And this we have not done through RDDs, this we have done through data frames or Spark SQL, whatever you say. So this is how we can do this. Just have a look at the code. This is your code. So what we have done is we have created our own user defined function, registered it, and the name of it is my function. We are using the same in our code. You can see how easy it has become. So I'll just copy this again here. Solution 2 using Spark SQL. So I hope this has given you some understanding. Because hands-on is required, do not always copy paste the code. Sometimes it's good to actually practice it yourself to get a lot of confidence, right? So on all of this stuff, I will keep on adding videos as and when required. However, I will be more focusing on these two things, in coming weeks, 1 or 2 weeks, right? So that you get a lot to practice on, a lot of coding examples, and moreover, a lot of interview questions I can cover. So I'll try my best to cover a lot in these two sections, right? But make sure you need to just not look at the video, rather practice it yourself to get a lot of confidence. And this question was asked in HCL very recently. So this is the trend kind of. They do not ask very heavy questions, but if you have not done little bit of hands-on, then probably you find it hard to even do this one, right? This is not tricky, by the way. Fine, then I hope you got a good understanding of this and you like the session. And let me stop the recording.